All right, and more solving, more solving. Okay, now what we're going to focus on today is what happens when we solve an equation where we have more than just x inside our grouping symbols. All right, so for example, you see that inside our absolute value is just an x here, but here we have x plus 2. Now we've talked about how to graph that, all right, but now what we want to do is see, okay, how does that translate to our solving process? So, all right, so here's what I want you to do, all right? So go ahead and complete, all right, parts A, B, C, and D. All right, sketch those graphs. You have two absolute values on A and B. All right, you have, all right, a quadratic and a quadratic. All right, I want you to sketch both those graphs. All right, find those points of intersection, and then flip the video back on, and we'll see how you do. All right, so let's take a look at the work. All right, so on the first one, right, the vertex is at 0, 0, right? And we get our horizontal line of 5, and we can see that we get 2 points of intersection here, 5, 5, and negative 5, 5. Now, the difference in the two graphs here is that now when I look at this, my vertex is at negative 2, 0. All right, so now my graph starts here. I still have the same rate of change. It still opens up. I still get 2 points of intersection, right? But it's negative 7, 5, and 3, 5. So it doesn't change how many points of intersection, it just changes where they occur, right? Now, same thing for our quadratic down here, right? Our vertex at 0, 0. All right, I go up 1, I go up 3, I go up 5, and I get 2 points of intersection. All right, I get negative 3, 9, and 3, 9. Now, difference here. When I look here, my vertex is just at 3, 0 instead of 0, 0. All right, and then I get y equals 9 here. All right, and so once again, if I sketch my graph, I still get 2 points of intersection, right? 0, 9, and 6, 9. So the difference is, all right, if I have more inside my grouping symbol here, it's just changing where those points of intersection occur. Not how many I have necessarily, right? But where do they occur? All right, so let's go ahead and flip over, all right? And let's look at the exponential problem together, all right? And so once again, all right, you should be able to do this, but let's go through this together, all right? So y equals 3 to the x. All right, that means our floor is at 0, so I'm going to draw that in. All right, we know our a value is 1 above the floor, or excuse me, our y-intercept is 1 above the floor. Then our multiplier is 3, so now I'm going to go to the right one. I'm going to go up 3, and then 3 times 3 is 9. So I'm going to go 2, and then I'm going to go up 9 right here, and there is my exponential. All right, just like that. And then y equals 9 is the horizontal line like this, and you can see that once I draw that in, all right, I get 1 point of intersection. They intersect at 2, 9. All right, now, look at this one, all right? We never graphed anything that had more than just an x in the exponent here. But let's start with the horizontal line, y equals 9. And I'll graph this one with you. Now, and I'm going to relate this to what we did here. So notice we had x squared here, right? And our vertex was at 0, 0. And then we had x minus 3. And so notice what this did to our graph. It just shifted our graph over 3 units. All right, same thing here, right? I was at 0, 0. Now this went to the left 2 units. So what's happening here is that when I see this x minus 4, this is really just going to shift this graph to the right 4 units. So instead of being at 0, 1, all right, my floor is still going to be 0, all right, because it's still plus 0 out there. But now I'm going to move this point to the right 4 units, so it's going to be at 4, 1. I'm going to move this point to the right 4 units, and now it's going to be at 5, 3. And I'm going to move this point to the right 4 units, 1, 2, 3, 4, all right, and that's going to be at 6, 9. And my graph is going to look pretty much the same, right? The only difference is it's now been shifted to the right 4 units, and I still get 1 point of intersection, right? And now that would be at 6, 9. All right. So once again, this idea, right? We're still getting these points of intersection, and when we have something else in here besides x, it's just moving it right or left most of the time. Okay. Now let's talk about how that translates to solving. So let's go down here, right? Still the same idea, right? We're going to set things equal. So we have the absolute value of x equals to 5. Well, if it's just the absolute value of x equals to 5, right, there are two numbers that have a distance of 5 from 0. We know that's going to be negative 5 and positive 5. And then we're done. Okay, and that's it. Now, notice the difference on part B here. We still have things set equal to each other, right? The absolute value of x plus 2 equals to 5. But notice now, Now I have to cover up what's inside here. So what numbers, right? What numbers have an absolute value of 5? That hasn't changed, right? That's going to be just still what we did right here. It's going to still be negative 5 and 5. But what's equal to those things is what's changing. So now x plus 2 could be negative 5. X plus 2 could be positive 5, right? Just like we're saying x could be negative 5, x could be 5. X plus 2 could be negative 5, x plus 2 could be 5. And notice this gets us back to kind of those first problems we looked at. Let's make them equal to 0. So I'm going to add 5 here. I'm going to add 5 here. So x plus 7 is equal to 0. What plus 7 is 0? Negative 7. So x equals negative 7 is my solution. All right, make this equal to 0. Subtract 5, subtract 5. X minus 3 is equal to 0. What minus 3 is 0? 3. So x would equal to 3. Now, notice if I go back over here, right, you can see, where do they intersect? Negative 7 and positive 3. All right, so the idea, right, is the fact doesn't change. What has an absolute value of 5? Negative 5 and 5. What's changing is what is equal to it, because now it's no longer just x. All right, and now we can see this again in our quadratic down here. X squared equals 9. So x squared equals to 9. All right, what number squared is 9? Well, it could be negative 3. It could be positive 3. Negative 3 times negative 3 is positive 9. 3 times 3 is 9. Okay, now go to this. All right, we still have it set equal, right? X minus 3 squared is equal to 9. Now notice here's the difference, right? What squared is 9? Well, it's still going to be negative 3 or 3. That fact isn't changing, right? That will always be true. What's changing is, okay, what could be negative 3? X minus 3 could be negative 3, right? What could be positive 3? X minus 3 could be positive 3. And then once again, now we're back to, all right, those basic equations. Let's get them equal to 0. So add 3, add 3. X equals 0, right? These are both 0. All right, minus 3, minus 3. Get this equal to 0. X minus 6 is equal to 0. What minus 6 is 0? Positive 6. All right, and if we go back and look, all right, we can see that there's an intersection at 0, intersection at 6. Okay, so that math fact isn't changing. Okay, that's going to be the same. What squared is 9 is going to be the same every time. Okay, but what we said equal to those values could change. All right, let's look at our exponential here. All right, 3 to the x is 9. So 3 to the x is 9. Okay, so 3 to what power is 9? Right? Oh, we know that's going to be to the second power. 3 times 3 is 9. So 3 squared is 9. Okay, same thing here, right? 3 to the x minus 4 is equal to 9. But notice now, all right, 3 to what power is 9? It's still going to be 3 to the second power, right? But now it's not just an x equal to 2, right? Now what's equal to 2 is x minus 4. All right, and so now when I subtract 2, I get x minus 6 is equal to 0. All right, and then what minus 6 is 0? That would be 6. And you can see that when we did that problem, right, if I slide back up here, that's where our point of intersection was at 6, 9. So the idea, right, is that we're going to look at the math fact. What is the math fact? And then the question will be, what is equal to that result, right? Okay, so let's go ahead and flip to the next page and just go through a handful of problems here. All right, and let's just make some connections. All right, so let's look at problem 1 here. All right, okay, absolute value of x is equal to 8. Well, what numbers have an absolute value of 8? It could be negative 8 or 8, right? So x could be negative 8, x could be positive 8. That's the math fact, right? That's it. Now notice number 2 here, right? If I cover this up, I still have something, the absolute value of something is 8, right? Well, that something is still going to be negative 8 and 8. That's not going to change, right? But what could be negative 8? X plus 5 could be negative 8. Okay. What could be positive 8? X plus 5 could be positive 8. All right. And then I can add 8, get this equal to 0. So x plus 13 is equal to 0. What plus 13 is 0? Negative 13. Okay. Subtract 8 to get this equal to 0. Subtract 8 here to balance it. X minus 3 is 0. What minus 3 is 0? 3. So x is equal to 3. So there's our two solutions. Now notice, I should have probably started with my sketching my graph, right? So if I go back to this graph real quick, right? my vertex would be negative 5, 0. So somewhere over here, it has a positive a value, so it's going to open up, right? And x equals 8. It's like that. So I can see that I get 2 solutions. All right. Same thing for this one, right? My vertex would have been at 0, 0. It opens up. 8's up here. I get 2 solutions. All right. Okay. So if you need that graph, right, sketch it. Now, we really haven't talked about how to graph these. All right. Now, before I move on, I'm going to start to talk about this. So notice if I go back and plug this in, right? We talked about verifying our solutions, right? So notice if I plugged in negative 13 plus 5, right, I can see what happens. So negative 13 plus 5 is negative 8, and the absolute value of negative 8 is 8. And so I know it works, right? So remember, we can go back and just plug those values in, right? So if I plug 3 in, 3 plus 5 inside my absolute value bars, and then 3 plus 5 is 8. So the absolute value of 8 is 8. Okay, and then 8 is equal to 8. All right, so you can see how this works, right? So the big idea is, right, the math fact isn't going to change, right? What numbers have an absolute value of 8? Negative 8 and 8, right? What's going to change is what could be equal to that. All right, so let's look at number 3. So once again, right, the absolute value of something is equal to 8. Well, what numbers have an absolute value of 8? Negative 8 and positive 8, right? Now, what could be negative 8? 4x could be negative 8. Okay. What could be positive 8? 4x could be positive 8. All right. Now, once again, now it's a basic multiplication problem. 4 times what is negative 8? Okay. Negative 2. 4 times what is positive 8? 4 times 2. All right. Is positive 8. All right. So the math fact isn't changing. You can see that we have the same math facts every time here, right? The absolute value of what is 8? Negative 8 and 8. What's changing is what could be equal to that based on what's inside the absolute value bars. All right, so let's go through and look at problems 4 here. All right, we have a quadratic, right? X squared equals 25. Vertex is at 0. It opens up. 25 somewhere up there. 2 points of intersection. This should make sense now. What number squared is 25? Negative 5 times negative 5 is 25, and positive 5 times positive 5 is 25. Okay, now, all right, so same thing here, right? I'm not going to do the graph here just for time's sake, but I'm going to just kind of get to the idea here. Okay, we still have something squared is 25. So what number times itself is 25? It's still negative 5 and 5. But notice what's changing is what is equal to negative 5 is 4 minus x is equal to negative 5, right? 4 minus x is equal to positive 5. All right, so let's get this equal to 0. So I'm going to add 5 here. Now remember, number to number. So I'm going to, even though the number isn't second this time, I got to find it, right? 4 plus 5 is 9. So 9 minus x is 0. 9 minus what is 0? And that would be 9. 9 minus 9 is 0. Get this equal to 0. Subtract 5 here, subtract 5 here. All right, so negative 1 minus x is equal to 0. All right, so negative 1, all right, is equal to, plus what is equal to 0? So negative x would have to be positive 1. And then remember, this is like a negative 1 here. So negative 1 times what is 1? Negative 1. So that's the process here. Okay, let's look at number 6 here. Once again, what squared is 25? That math fact doesn't change. It's still going to be negative 5 and 5. Okay, but now 5x could be negative 5. Positive 5x could be 5. All right. Okay, and then once again, now we're to math problems, right? Okay, just basic multiplication problems. 5 times what is negative 5? Negative 1. 5 times what is 5? Positive 1. And there's our solutions. All right, I think I'm going to wrap up the video right there. All right, we'll continue. We'll look at some exponential problems. All right, next time I see you in class. All right, have everything ready and any questions you have, and I'll see you then.